My thing went on. Low key, that's my touch with you.
Okay. All right. To see my audio, share my screen. Testing. Testing. Hopefully, there's not a bad broadcast. All right, gentlemen. I'm gonna do the best I can with the announcements. I did better this morning. If you want a more thorough recap on the announcements, probably listen to the intro from this morning. So let me see some things to bring to your attention. So one, be aware I am live streaming this to my YouTube channel. So, just kind of keep that in mind. You can, I basically what I'm trying to do is, with my sessions with the students this semester, I'll put them all. There's like two main playlists that you need to access. One is the one from this term. So basically like this session last week, and anytime I engage with the students, I put it into one folder called Fall of 2022. 2024. And then there's another one that says, all pre-recorded lectures for College Algebra 1. So this course is just College Algebra 1. There's no lab component. So hopefully over the weekend, many, if not most or all of you, hopefully you were able to gain full access to Pearson, My Lab and Mastering. And yeah, that was the meat and potatoes there. So I'm using a microphone. So what that means is like if you try to do the audio, I won't be able to hear you. So just if you have questions, feel free to either type it in the Q&A or in the chat. I am monitoring those. And then also, hopefully you all were able to connect on your group me. I had to kind of remind my students earlier, and there were like a lot of guys that didn't know about it. So I don't know if you've all started a group me or not, but so it's a good idea to follow up on that. And again, if you have questions, for right now, either feel free to either type it in the chat or put it in the Q&A, and so we can make sure that they get addressed. Let me see if there's anything else. And then just to kind of recap on ways that you can gain full access to Pearson, the recommended route, it's a group me, so in the chat. So the recommended route is, you log in a Blackboard, you open up our main folder that says College Algebra 1, and then you'll find a link that says Access Pearson, all my assignments or something like that. And then you click on the link and follow the prompts and purchase it directly from there. So that's the recommended route to purchase access. A second route is, I know sometimes students have to use book vouchers. So if you have to use the book voucher, or if you're using the book voucher, you can purchase it out of the bookstore, but you just have to be sure to purchase a MyMathLab access code. So just make sure it comes with the unused MyMathLab access code, and then you're good to go there. And then the third option is like, if you buy a hard copy book, just make sure it comes with an unused MyMathLab access code. Right, that's the main thing there. There was something I was trying to see if I can pull it back. Let me see. Then there's an echo. Let's see, can I reduce the volume of this? That might help. Yeah, for whatever reason, it won't let me mute my phone. It just lets me do it really low. I think we're good there. Okay. There was something else I had a moment ago, and I'm trying to recall it. We talked about the homework. We talked about Pearson. I can't think of anything else. So yeah, again, it just wouldn't hurt to watch my intro from the morning group from the 9 a.m. Just to make sure you got everything. Okay, here's another one. So if you missed last week, remind me at the end of class so I can mark you as excused. Like these first few sessions, I'm kind of lax on the attendance just because I know everybody's trying to find their way. But yeah, and yeah, I can't think of anything else. I felt like there's some other things, but we'll kind of let that be. Now, so the goal for today, so we kind of want to get started with our content, again, making our way through these materials. So now notice. So I think on today's slide, so let me say this. So anything that you see me writing here, I'm gonna make a copy available in Box. And so you access it again. Our central hub for everything is Blackboard. So if you're trying to find something, you just start in Blackboard. I put everything there. So at the end of class, and there's actually a copy of it available right now from our earlier group, but you can log into Blackboard and then open up the Box link. It's going to take you to an exterior app called Box, and then you should see like about 5 other folders. Like one will be the syllabus, and then you'll see a folder number 2 that should say daily lecture notes. And so if you click in there, you'll find the current notes for each day. I usually load the notes on a day-by-day basis. I think I put some reference files in there as well. So, we have 50 slides. We only have 50 minutes now. I don't really intend to get through all of this together. We'll do the best that we can, but I'm going to rely heavily on my pre-recorded lectures. All right, so the pre-recorded lectures on my YouTube is pretty much the exact same content, but I took my time and went through each and every example. So it's a recording that kind of makes up for the time that we don't have when we're together. So that way, when we're together, we don't necessarily have to rush. But whatever we don't finish together, I expect you to use my recordings. And then again, in an ideal world, hopefully you guys can start looking at these and get ahead a bit so you're not playing catch up when we get in class. Okay, and again, as usual, as always, if anything is not clear, feel free to either type it in the chat or put it in the Q&A. I am monitoring these. The session is being recorded. Also, the session automatically records attendance, right? So what that means is it notifies, it records when you show up and how long you were here and when you leave, right? So, be careful about dipping out early. The simple thing is, just log in and you can zen out. In the past, I used to kind of hound you guys like, hey, so-and-so, turn your video on or this, that, and the other. That was too much for me. I was like, you know what? F all that noise, right? So the compromise is if I'm not going to hound you at a minimum, just get in here 5 minutes early and zen out for like 50 minutes, all right? And, either listen or not, you're an adult, all right? So I'll let you make these decisions for yourself. I don't go too much deeper into that. But if you decide to zen out, you're an adult. So I'll let you decide for yourself. View settings, I'd like it as a single page. Okay. So if anything else, because I think there are a few other things, but one other thing. See, I know it's a lot because we're just kind of getting acclimated to everything. So I will make a copy of all the stuff that you see me writing available. And again, actually there is a copy available now for my morning session, so you could pull that. But again, after each session, I'll load the PDFs there. And so I'm saying this to say, so my recommendation is that hopefully each of you guys are making your own notebook, right? So having access to notes and making the notes are 2 different things, right? Having access to notes in the book and stuff like that, then, when the exam comes around, then it's just a research thing. You're going back and forth trying to find stuff, and it's not really going to serve you versus you kind of take your time, you're making a notebook that's neat and organized. The magic comes in making your own notebook, not having access to a notebook, right? And this, I'm speaking from experience, right? Because I've tried both tracks. Like, professors say, oh yeah, it's open notes, you can use your notes. and I shirk things off, and then I get to the exam and I get a copy of the notes, and I'm just flipping back and forth trying to find stuff, and it doesn't serve me. Versus when I make my own notebook that's neat and organized, by the time I get to the exam, I don't even need it at that point. I just know it because I've spent all this time making the notebook, right? So if you are going to make a notebook, which is again highly, highly, highly recommended, there are three main things that you need. One, in one part of your notebook, you have a copy of the notes. So, these things that I make available at each session, like we're going to make our way through it today as much as possible. Another part of your notes are the homework, right? So a copy of the homework where, again, it's imperative that you're neat and organized, where you might say, okay, this is section 1.1, graphs and lines. Here's question number 1. This comes from section 1.1, question 3. That's the question ID. Here's a copy of the original question. Here's all the supporting work. Here's my final answer in the box, all right? Here's question number 2. This comes from 1.1, question number 5. Here's a copy of the original question. Here's all the supporting work, final answer in the box, right? You do that for everything. Again, it's tedious. It is really tedious and boring, but that's how you learn it. All right. We haven't gotten to that level of being able to download in the matrix. So this is a marathon, right? So that means you kind of got to set aside anywhere from 2 to 3 hours, about 4 days out of the week for this material, right? That's about how long it takes. And then the third part that's needed in your notebook is a formula sheet, right? So like for instance, like today we're going to be looking at chapter 1, graphs and functions, and we're going to be kind of working on section 1.1, graphs of equations. As you kind of glance at these objectives, like objective number 2 is find the distance between 2 points. Objective number 3, find the midpoint of a line segment. Those are formulas that, I would highly recommend that you include on your formula sheet. So the formula sheet, my recommendation, put it like at the back of your, at the end of your notebook. And then every time we come across a formula, update your formula sheet with that formula, right? So having a neat, organized notebook with those 3 things that you create yourself, not that you borrow, that you create yourself. It takes time. You have to set aside time. You have to slow things down. And I know it's challenging with, this microwave generation and internet. And we stand in front of the microwave tapping our toes like, what's taking so long? We want everything yesterday. The rhythm of this is different. It's a slow, you have to slow things down. It's not really fast paced, but it's more so information overload. And it seems very unassuming, but if you procrastinate, what tends to happen is it comes a point where you're not only contending with mathematics, but then you have your 4 or 5 other classes, sometimes even 6 other classes, where if you don't manage your time properly, it can get kind of nasty. So yeah, the notebook, gaining access to My Math Lab. One other thing about My Math Lab, I know it's a little bit long intro, but some students were trying the links and the link wasn't working. So like, for instance, if you're on a Mac, you need to make sure to allow pop-ups. It really doesn't matter what system you're on, but on all the systems, you need to allow pop-ups and allow cookies. Right. So if the link isn't working, make sure you're allowing pop-ups and allow cookies. Reboot your browser and then try it again, and you should be good, Gucci. Okay. I think that might be everything. I'm hoping so. Again, if anything pops in my mind, then I'll kind of keep that in mind. Okay. So moving on to section 1.1, graphs of equations. So again, we'll do the best we can here. Whatever we don't finish together, I do expect you to use my recordings. And then on Wednesday, so we'll do the best we can with the lecture today. And then on Wednesday, the goal is to go through as much of the homework together as possible. Also, I think that this upcoming Monday is Labor Day. So Labor Day, we don't meet. All right. So Labor Day, we don't meet. I think the school is closed. Okay. So looking at section 1.1, graphs of equations, the objectives that we like to work on: 1, plot points in a Cartesian coordinate plane. 2, find the distance between 2 points. 3, find the midpoint of a line segment. So we got 2 formulas right there. We're going to hopefully update our formula sheet by the end of the day. 4, sketch a graph by plotting points. 5, find the intercepts of a graph. 6, find the symmetries in a graph. And 7, find the equation of a circle. Okay. So we have some definitions. An ordered pair of real numbers is a pair of real numbers in which the order is specified. All right. So let me see. Let me grab this. We can disable this for now. And let's go. Sure. Let's change that to this. Okay. So for instance, this guy here is called an ordered pair because the order is important. It's a pair of numbers where the order is important. All right. So the first component is our x component. The second component is our y component. Our x values go side to side. Our y values go up and down. So when we're plotting these points, right, we're going to basically see the xy coordinate plane. And then we're going to start at the origin. This one says, we go left 3 and then we go up 1. All right. And then we put a point. Okay. Two ordered pairs, x comma y and a comma b are equal if and only if x equals a and y equals b. So they're equal if and only if the corresponding components are equal. Okay. So here's our Cartesian plane, right? We have our x-axis. So x-axis, we say it goes side to side. Our positive x-axis is going to the right. We see the label for x there. Okay. Our positive y is going up. We see the label for y there. All right. So then when we take these two axes and cross them at a 90-degree angle, right? 90-degree angle could be like the corner of the TV, the corner of the table, the corner on the wall, right? The 90-degree angle. What it does is it breaks the flat surface up into 4 quadrants, all right? 4 quadrants. So in the upper right-hand corner, we have quadrant 1. That's where x is positive and y is positive, quadrant 1. Just in the chat, what direction is this? If we're going in this direction, what do we call that direction? All right, what is this called? Going in this direction? Anybody tell me in the chat? Anybody got that? Correct, right? Counterclockwise. 10 points for Gryffindor. This is what I feel like saying, but obviously, we don't have Gryffindor or anything like that. Side note, I think there's a school here in the city of Atlanta that is designed after like Harry Potter. Like supposedly, like when you go into like the main lobby or whatever, there's like a giant dragon that like shoots fire. It's so weird. Like I haven't got a chance to tour the school. It might be either a middle school or a high school somewhere here in the city of Atlanta. So you might be able to find something on it online or not. There's that, and then walking on the Beltline, you hear people behind you talking and chattering. And one kid was talking about this school in Alabama where they have different houses similar to Harry Potter, and he was just talking about it. Just sounds like really interesting. I was like, oh, it sounds like fun. And it is kind of designed like Harry Potter, but I don't know that they did the actual physical construction. But they had like different houses and they had competitions and things like that. So that was like, that was kind of fun, cool, whatever. But yeah, so going in this direction is like counterclockwise, right? So if you think about the hands on the clock, they traditionally go in this direction, that's clockwise. But when we're counting the quadrants created by the orthogonal axes, orthogonal just in this context just means like 90-degree angle. We count them in counterclockwise fashion. So the upper right is quadrant 1, and then as we move counterclockwise, now we move to quadrant 2, where x is negative and y is positive. Then if we keep going to quadrant 3, x is negative and y is negative. And then finally, we finish in quadrant 4, where x is positive and y is negative. Okay, so hopefully we're all aboard and we're not all aboard. And again, if anything is not clear, feel free to either put it in the Q&A or put it in the chat, and we'll make sure to get it addressed. Right now, I can't hear your audio just because I'm using a microphone. Maybe at the end of class, I'll disconnect the microphone and we can kind of work that as needed. Okay. So, again, this is just kind of recapping what do we mean by an ordered pair? And it's basically the ordered pair is like are like directions or GPS directions to a specific point on the flat surface, right? If we start at the origin, then it's instructions how to get to a specific point on the Cartesian plane, right? And so I'm going to leave this as an exercise. This is basically plotting points. This will become second nature if it's not already second nature. For instance, what quadrant is this point in? Right? What quadrant would we say that is? If X is three is correct, right? That's quadrant three, right? Because this is basically saying we start at the origin, we go left three and then down four. So left three and down four puts us right here, and that is indeed quadrant three. All right. So just a quick recap: upper right is quadrant one, upper left is quadrant two, bottom left is quadrant three, and bottom right is quadrant four. Okay. All right. How would you describe? So, for instance, if A is in quadrant one, B is in quadrant two, this is quadrant three, this is quadrant four. How would you describe the location of E? How would you describe the location of E? And you can type it in the chat, or because again, I can't hear the audio. So, okay, along the x-axis. Okay, that's fine. Yeah, right. So you could say it's sometimes these are called like quadrantals, like meaning they're on an axis. But yeah, you could say that this is on the x-axis. Yada yada yada. Okay, cool. All right, I think we're Gucci there. All right, not too bad. Okay, so here now again, I know we just kind of mentioned it today, but if you have a formula sheet, this is a great formula to include on your to update your formula sheet with. We have the Pythagorean theorem, um, and basically what it is. Let me see if I can get this to work. Anybody got a favorite color? Anybody got a favorite color? Hmm. Okay, let's see what else we got. Blue, green. Okay, it's interesting. Yeah, I don't know why do we all kind of choose like so I think my earlier group said similar colors. I think there was also a purple in there, black. Okay, I like black. Blue, green, and black. Okay, so let's see. Let's start off with blue, right? Um, so again, when it comes to Pythagorean theorem, basically what it was that like a mathematicians back in the day, they just sat around and just thought about shit. Like it's like they have nothing better to do to just sit around and figure this stuff out, right? Now, in this day and age, we're all distracted with social media or chasing our tails or chasing money. So we don't get a chance to sit down and figure out the mysteries of the universe, right? Until we can get past these, like, don't get me started into all my conspiracies on how this stuff is intentional so that we're chasing our tail and we don't get a chance to sit still. But if you're ever able to build your life where you get the opportunity to sit still, maybe you can like make up your own formulas and figure out some other things. There's a lot to be figured out. There's still a lot left to figure out. We just have to get past this corruption that's going on with our leaders. But so let me see if I can make a square. I think that's a square. I think that's okay. That looks decent. So let's duplicate this. And so I think I saw green. And then let's duplicate this. Now this one's a little bit challenging. Okay, I think what I'll do for this one, we'll do it in this color. That's fine. I'm just trying to do it. I know it's gonna be a little off. It's really supposed to be a square. Kind of needed to be a polygon now. Not responding to that. He's not checking again. Let me see if I can get this to behave better. Let's delete this. Let's go like this, like this. I just want like a polygon. still snap into rectangle and square. Okay. What else could I do? Just want a polygon. See, for whatever reason, it does. Oh, is it doing it? Not quite. That's frustrating. Okay, I got one other technique I can try, which I was avoiding. I didn't really want to do an oblong shape. I wanted to behave like this, but I wanted to be four-sided. And for whatever reason, because it was four-sided, it didn't want to behave. So I was like, okay. Now this one is, there we go. Okay, that's better. So this is, I'm just going to do my best to make this like a four-sided figure. And it's really supposed to be a square. I think I just don't have enough space. Kind of running short on space. Hopefully you guys are not hearing the echo. So again, this is really supposed to be a square. What if I pull it like this? That'll do it for now. It's really supposed to be a square, but like I say, it's just a little bit misbehaving. But okay, so basically what it was is that, so a mathematician realized that if he squares the two legs, like if you take the square of leg A plus the square of leg B, then it equals the square of the hypotenuse, right? So that was the long and short there, right? So the sum of the squares of the two shorter legs equals the square of the hypotenuse. Let me send this real quick. Reply. Check for it again. All right. Okay. Let's see. That's okay. Yeah. So no, the way we're doing attendance, I think I've got the automatic attendance working. So you hear, it'll be okay. Yeah. So it's just an automatic. Okay. So Pythagorean theorem, basically the sum of the squares of the shorter legs equal the square of the hypotenuse, or a squared plus b squared equals c squared, right? I know that last one's not a square, it's supposed to be a square, but it's kind of acting up a bit, and I got tired of fooling with it. So okay. I think I'm gonna just get rid of these. Just not fill them. Okay, that's fine. So then here, space. Nope, undo. Here. This one. Like that. Come on. Okay, that looks good. And we're gonna put you like about here. So, all right. So we just kind of introduced the Pythagorean theorem. Let me grab, move you here. You go about here. Okay. So then now let's kind of take a look at the Cartesian plane real quick. Say this is our origin here. Say the positive x goes in this direction. Okay. Positive y value goes in this direction. Nope. Let's try it again. Try it again. It's a little bit off. We'll fix it. Okay. And let's move this guy. Okay, that looks good. All right. Okay, and we want to consider 2 points, right? So say we consider this point P here, and we got this other point over here called Q. So this will be P. We're going to label it as X1, Y1. And we're going to label this point over here Q as X2, Y2. Okay. And so we want to consider the distance between these 2 points, right? We want to develop some kind of expression for the distance between these 2 points, all right? What's the time? Okay. Okay, so if that P is the order pair X1, Y1, so then this down here corresponds to X1, here corresponds to X2, right? I think I like this better, like this, right? Here corresponds to Y1, and here corresponds to Y2. All right, this shape should look familiar, right? I think in the previous slide, we said something along the lines like this is what our A, this is our B, and this is our C, our hypotenuse, right? So using the Pythagorean theorem, right? And I think in the previous slide, we just said A squared plus B squared equals C squared, right? So then if we want to calculate the distance of A, right, a length of A, right? Say 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Like if x2 were 7 and y1 were -5, how could we get the distance between those two guys? What could we do to find the distance between x1 and x2? What operation could we do? Anybody give me a suggestion there? How can we find the distance between on the x-axis between x1 and x2? What could we do? All right. How can we find the distance that x2 is away from the origin or from the y-axis? How can we find that distance? Oh, I just knew you guys had it. Okay, so if we want the distance here, there it is, close, close. You got that's the main word I was looking for, subtract, right? So if we want the difference between this guy and this guy, then we can subtract, right? If we said, like for instance, if this were 7 and this were -5, if we said 7 minus -5, right? Then I think that would give us a distance of 12, right? Which is their distance, right? So if we want the distance along the x-axis between x1 and x2, then we say subtract, right? So we could say something like A might be equal to the absolute value of x2 minus x1. Okay, let me check the chat real quick. Yeah, that's good. Okay, so then something similar for B. B might be the absolute value of what? y2 minus y1. Okay, so that's how we could find the distance of A, the distance of B. So then if we plug these into our Pythagorean theorem formula, where C is going to be the distance between P and Q, so then we might have something like the following. Well, I guess we'll go here. The distance between P and Q, quantity squared, which is our C, is A squared. So that's going to be this x2 minus x1 squared plus B squared, which is y2 minus y1 squared. Okay. So real quick, right, exactly. So in the chat, can somebody describe to me what do we mean by absolute value? What does absolute value mean? Like, can you describe absolute value for me? The total, right? The total or positive distance from zero, right? The positive distance from zero. So, like for instance, if we said the absolute value of 7, that's going to be 7. Absolute value of -3 is going to be 3, right? So absolute value is the positive distance away from zero. So then, if absolute value is a positive distance, what happens if we square a positive number? What happens if we square? Does it stay positive or does it become negative? What happens positive, right? So we're taking a positive number and squaring it, then we can essentially lose the absolute value because, well, it's not going to be negative because of the absolute value, right? So there's a little bit of redundancy here. So, and we can also go ahead and solve for the distance between P and Q. We can move that square to the other side. what's the inverse operation? How do we move squared to the other side? What do we take on both sides? Let's take the blank on both sides. What's the blank? Take the blank on both sides. How do we get rid of this square guy? What do we do to both sides? The inverse operation of squared will be square root. One other thing with square root. Usually, whenever we take the square root, what symbol do we need to include? It's kind of duplicitous. It's kind of two-faced a little bit. Not necessarily bracket. Generally, if we do an even root, we have to go once, go twice. Okay. So you plus or minus, right? The symbol plus or minus. In this context, because we're only working with distances, we're working with positive distance, we're only going to take the positive. But usually, if we do square root, we include plus or minus, right? But you guys got it. You got the idea. So if we take the square root on both sides, right? We're going to do square root here and square root here. This symbol is going to cancel that. And now that's basically where the distance formula comes from, right? So the distance between, as a matter of fact, let's back up. The distance between P and Q is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared, right? So that's where the distance formula comes from. Now let me see if I can get this to work because I know how temperamental this thing could be. There it is, and it's still doing that. So what I have to do, can expand that. I think if I hopefully this isn't anything sensitive. That's okay. I just need this to behave. Come on. Still doing it. Okay. So let me get rid of this. What did I do earlier that got that to work? What else could I do? Wasn't full screen. Sorry, my device is being a little bit temperamental. Basically, this text box is like too big, and so when I'm trying to access my options, it's not showing. I think I have to do it. See, and that's what I'm avoiding. That's not it. Let's just put that back. There was some technique I tried earlier. Oh, I know what it was. View settings seamless, and I think that'll get it to behave. This one, and okay, yeah, I can work with that. All right, now we're back in business. View settings, single page. Okay. All right, Gucci. All right. So in green at the bottom, so basically what we experienced here is what's called, okay, I see we got about 5 minutes left, and that's okay. It's called a derivation, right? So these formulas, these aren't just random formulas that they pulled out of thin air. They usually come from some kind of train of thought like this. They already had the Pythagorean theorem. We wanted to find the distance between 2 points, and then they saw a correlation between Pythagorean theorem, right triangles, and finding the distance between 2 points. So an application of Pythagorean theorem is the distance formula, right? And so this was a derivation, where the formula comes from. So if you have your formula sheet, it's a good idea to update it with this formula. I'm going to do a quick scan of the remaining slides, right? And so this was just reiterating what we just experienced as far as the distance formula there. So how we derived it. I'm going to have to leave this as an exercise. Okay. And the solution is here as well. So again, a copy of these notes are available now, and I'm going to make a copy of what we're experiencing together as well. So basically, I have 4 different sections that are doing the same thing. So once I hit my 9 o'clock, you can always pull a copy of theirs. But I put all of you all's content pretty much together. If you wanted to access a copy of these notes, you would go into Blackboard, open up our main folder. This is College Algebra 1. Then you'll see that whole Zoom link. You'll see, I think it's box links notes, right? I think it's item number 2 in Blackboard. And it's in there. So it's going to take you to Box. You log in with your Morehouse credentials, and you should be able to pull the PDF there. Okay, so this is a midpoint formula. I'm going to just highlight this in green real quick. So, it's a good idea. Here it is. To include this in your formula sheet, midpoint formula. That's a little bit better. Point, average of my x's, comma, average of the y's. Okay. Average of the x coordinates, comma, average of the y's. Now, again, if you want to see a more detailed explanation of some of these, if you use my my playlist on YouTube, it has all of these examples worked out in detail. It's just we're limited to like 50 minutes together. We only got about 5 minutes left. Yeah, let me kind of scan. I left this one as an exercise. I'm gonna scrap this and paste. Okay, so I'm gonna leave that as an exercise. But it's worked out here. So when you pull a copy of these notes, when you're reviewing your notes, like these that I'm leaving as exercises, it's a good idea to try to work them on your own first. Try not to look at the answer. See how far you can make it on your own. And then if you get stuck, once you finally get to an answer, then compare. Don't start with the answer, right? Try to see if you can develop your own answer. And the more you're able to be accurate without, piggybacking off the notes, the better, right? Okay, let me see what else we got. So more often we're going to refer to the x coordinate as the independent variable and the y coordinate as the dependent variable. Oftentimes, like we'll choose the values of x as independent, and then the y value is going to depend on what x value we choose, right? So that's kind of the long and short there. And so the graph of an equation is basically the set of all ordered pairs that make an equation true. So when we start working these examples, we're going to choose several values of x, pass them through our equation. We're going to generate the corresponding y's, and then we're going to plot all these points on a graph. And the graph is going to be a pictorial representation of all ordered pairs that make the equation true. So hopefully that made sense and it wasn't too much of a mouthful. Again, I'm going to have to leave this one as an exercise. We chose these values of x, pass them through the equation. We're going to generate values of y, and then plot the ordered pairs. I think we have it typed up here, so you can always use that. When we plot it, we get an image like this. Okay. So sketching a graph by plotting points, you plot your ordered pairs that you have, and then basically connect them with the smooth curve. If it's a line, connect them with the straight edge. And then we have this notion of x-intercept and y-intercept. If you think about the word intercept, all right, what does it mean? What does the word intercept mean? All right, it means what? To cross or touch or things of that nature. So the x-intercept is where the graph is going to cross the x-axis. The y-intercept is where the graph is going to cross the y-axis. Anywhere along the x-axis, the value of y is always 0. Anywhere along the y-axis, the value of x is always 0, right? I'm just doing a scan. Again, you can use my recordings to kind of slow down the rhythm and fill everything in. If we want to define the x-intercepts at y to 0, if we want to find the y-intercepts at x to 0, I have to leave this one as an exercise. All the way at the end, paste. And the solution is here. Symmetry is when 2 points are mirror images around either an axis or another point, and they're equidistant, right? So for instance, this point P and this point P prime are symmetric about this axis, this line L. They're the same distance away from L, and they're mirrored about L, okay? So then we have this idea of y-axis symmetry. With y-axis symmetry, whenever we have x comma y, we also have negative x comma y. So basically the y-axis will cut our image in half, and the left half is going to be a mirror image of the right. We got a solid minute. Let me just kind of focus. Um, so then we have x-axis symmetry, right? So with x-axis symmetry, whenever we have x comma y, we also have x comma negative y. All right. So notice that the x values are the same, but the y's change sign. So when that happens, the x-axis serves as an axis of symmetry. And then the third one that we have is called origin symmetry. That's where all the points are equidistant and symmetric about the origin. So whenever we have x comma y, we also have negative x comma negative y, right? And it tends to make like an S shape, but all the points are mirrored about the origin. So we have a test to find whether an equation has any of these symmetries. I'm going to have to leave that as discovery for you. It will come out if we, either when we're working on homework, but if you go and watch the recordings, all those details are there. Another recommendation is when you're watching the recordings, you can put it on like ×2 speed. And I know some students will do that because that helps them to get through the whole video faster and they can still hear what they need to hear. Right? It's kind of interesting. I thought it was an interesting technique. Okay, so I'm going to have to leave this as an exercise. And again, these details are in my video. They should be because I took the time to, all of these are exercises. And then, so this one right here, with your formula sheet, it's a good idea to update with this formula. I see the time, I'm wrapping up. I'm about to get you guys out of here. So if you have a formula sheet, it's a good idea to include that. We don't use this one too heavy, but since it's there, just go ahead and include it. Watch the video on it and, make sure you have it. I'm going to leave this as an exercise, paste. And the solution is there. All of these are exercises. So give them a go on your own. And then if needed, either use the notes or use the recording. We have the general, it wouldn't hurt to add this to your formula sheet. I'm just going to highlight it real quick. General form of the equation of a circle. Okay. It's a good idea to have that one. And it takes a little bit of effort to manipulate it. And that pretty much gets us to where we need to be. So I know there was a little bit of a crash course on this section, but again, our time together is limited. So if you want to see a more normal paced presentation, you have to use my YouTube and use my recordings. Okay, so these are my YouTube channel. One way is you can go to YouTube and search for Beautiful Mind Phifer. It's a basic channel. I don't even have a logo yet. So just, it's purple. You'll see it. Or if you go to Blackboard, again, if you're ever trying to find something, Blackboard is like our central hub. I put all the links there. So when you open up Blackboard, open up our main folder, it should be like one of the last links. You'll find it there as well. Also, when you go to start the homework, I think one of the first prerequisites I created was that it connects you to my YouTube channel. So it's at least 3 different source places where you can find the link. That's a good question. Any other questions? Going once, going twice. Forever hold your peas and rice. Okay, so I'll be updating unit 1. So we're not doing units. Yeah, we're not doing units. These are like sections. Hopefully you're not supposed to be in that college algebra 2. You can label this as section 1.1. Like I think section 1.1, if we go back to the top, was called graphs of equations. So this week is just section 1.1, graphs of equations. So on Wednesday, we're going to go through as many of the homework questions together as we can. Okay, Mr. Kojo, what kind of device are you working on? Here, let me kind of close out, and anybody that wants to go, I can release them. Let me just see if there are any final announcements. So yeah, the main thing is getting my access to my math lab. So again, one issue that some students have when trying to access my math lab, like for instance, if you're working on a Mac, even if you're working on Windows, you have to make sure to allow pop-ups and allow cookies from Pearson, right? So allow pop-ups and allow cookies. Otherwise, you'll get an error message and it won't let you kind of move forward. So just try changing those settings. Like for instance, if you're on a Mac, you might have to open up settings, scroll down to Safari, and then again, allow pop-ups and allow cookies, and then reboot Safari, and then proceed like that. If you're working on like Windows or Chrome or something like that, again, same thing. Go into the settings, allow pop-ups, and allow cookies. Reboot it, and then give it a go there. So again, go ahead and gain full access to Pearson. Again, the homework is assigned. I've already made all homework and quizzes available for the entire semester, so you can actually get ahead. The only thing you're going to be waiting on are exams. The exams are scheduled to release every 3 sections, right? So we're working on, is that right? Or every 3 weeks. So this is like the first of 3 weeks, right? So we got this week, we got next week, week after next. So we're doing 1-1, 1-2, and 1-3. So once we complete section 1.3, then the next week we're going to have exam 1 over those 3 sections, right? I think that's the rhythm that we have for everything. Hopefully I answered the question that was in the chat so that you can gain access. Are there any other burning questions before we go our separate ways? Let me go ahead and make a copy of these notes available. So you actually have access to this morning's notes and you all's notes. It's really the same thing, but if you want ours specifically, and they're going to be side by side. So you just choose whichever is your prerogative. I'll load that in just a moment. Is our formula sheet on paper or do we make it online? It's up to you. This is your own notebook. You can make a digital notebook. Just as long as you're neat and organized and you can find everything you need, right? When you need it. This is all for you. So I'm not, this isn't like required or anything.
Excuse me, I had a question.
All right, I'm going to stop sharing my screen real quick because sensitive stuff be popping up.
Dr. Phifer?
Stop sharing. Let me go ahead and make a copy of the notes available. Okay, that's fine. I want to share. Send it to box. Oh, come on. Let's back up. Back. Oh, do I need to like log in or something? Oh, shyster. All right, so I'll make this available momentarily. Yeah. Okay, I guess I'll go ahead and make it so that I'll remove my mic so if you do audio, you can do it. Do we have to send you? No. Notebook is just for you. On the Mac. So you're going into, with the one that's on the Mac, what kind of error message are you getting? Or what kind of error message are you getting? And you can do the audio now.
Okay. Thanks, sir. Please, the message I'm getting is sorry, we couldn't open your call.
Did you go into the settings and allow pop-ups and allow cookies?
Yeah, I did allow third-party cookies.
You got to also allow pop-ups.
All right.
Manage accounts. Log in the box. Continue. Single sign-on. And the email address is correct. So I'm having to log in the box so that I can make the notes available. It's just a little bit trippy. Okay, so while I'm doing this, if there aren't any other burning questions, then we're going to go ahead and end the session here. We'll meet back on Wednesday to kind of go through as many homework questions together as we can. Let me go ahead and release those that need to go. And from one beautiful mind to another, take care. We'll meet back on Wednesday, same time, same place. If you still have questions,
sir, please, is the work on
go ahead.
Is the work on my MATLAB?
What about it?
Is the work on my MATLAB?
I'm not understanding your question.
The homework is on my MATLAB.
Oh yeah. So all homework quizzes and exams are in my MATLAB. So that's why that's how we're gonna do our grading.
Yes. All right.
And oh sorry.
You good?
Which one should we purchase? You've given us 2 options.
What are the names?
When I could log in, I saw the names, but because I still haven't been able to log in,
one of them was like 150 and the other was like 120. I think the 120 one is fine because all you really need is the access to my MATLAB. If you want to go for the more one, you can, but it's not necessary.
All right. Thank you. I'll inform you whether I can get on to my MATLAB.
You're still not able to?
Yes, please.
Is it how do you pronounce your last name?
Odampton.
Odampton. Okay.
Yes, please.
Did you allow cookies and you allow pop-ups?
Yes, please.
What kind of device are you working on?
A Mac.
How are you accessing it?
Through Chrome.
So are you able to log into Blackboard?
Yes, please.
And you're able to open up our course?
Open up the course as
in Blackboard.
Yes, please.
And then
it used to work, but then it just logged me out. It kept on saying you can't log in again.
maybe screenshot the error. Just try rebooting. You might have to reboot and you might have to wait a little bit, because if you've gotten in there once, then that means that it's not anything with my link. Sometimes it is just temperamental. Just give it a bit. Screenshot the error, send it to me, and you might have to reach out to Pearson. It's either Pearson.
Wait, it's working now. Thank you. I can see it's working now.
Sometimes it's just temperamental. So yeah, okay.
So I should purchase the single term access, right?
Yeah, you can do the one that's 120. I think there's a 120 option and a 150. As long as you have the MyMathLab access, that's all you really need.
There's what I'm seeing is 149 and 149 and 699 a month.
No, so you don't need all of that. You just need the
so you just get the one-time access.
Yeah,
the single term access.
Yeah.
All right. Thank you. Have a good day, sir.
You as well. Okay, so I was able to log in. I'm just making the notes available. I don't know why, again, technology being temperamental. Okay, so export the box. Okay, so I just made a copy of the notes available. I do kind of have to get ready for my next group. Yeah. Okay, guys. So we'll meet back on Wednesday, same time, same place.
Got it. I just wanted to make sure you had me because I just transferred in and I came a little late because I got the time mixed up.
What's your last name?
Jean Baptiste.
Did you take me for something else? You had a brother or something that went here?
No. It's a popular last name.
Oh, okay. Okay. Yeah, you should be good. Attendance is taken automatically, so as long as you get into the Zoom call, then you'll get credit. Yeah.
Got it. Thank you.
We said please also have two first names. I have Niso and Kojo, so I wanted to know which one, like whether you still see my attendance.
What's your last name?
Odampton Soa.
I see both of them.
All right. I just wanted to know.
Yeah, I think you're good. It's as long as you're showing your like student name, then when I go to do attendance, I can find you. I had one person earlier that had Zoom user. I was like, I don't know who that was. So yeah.
All right.
Okay.
Thank you, sir. Have a good day.
As well. I got like 2 minutes. No. So basically, this is like my 2:00 is just wrapping up. I know we got 2 minutes before my 3:00, so it's just overlapping. Yeah. So we're just gonna kind of zen out for a minute or two. I'm gonna connect my microphone back. So yeah, it's no worries.
So I just connected my microphone back. So whenever I have my microphone, whenever I'm using it, I can't hear you guys' audio. So just kind of be aware of that. I guess I'll check that later. Let's go here. Let's go to the 3:00. Make sure we're at the top. I am exhausted. And I really like the automatic attendance stuff. That makes things so much easier, so much more smooth. Let me clear this out because this is all from my earlier group. We should be good there. Okay, and I want to share my screen. Start the broadcast and optimize the video. All right, so we got about another minute. I don't know if you guys are aware. So like at the bottom of the screen, I have my doc pulled up. I'm working on an iPad. And then my second app from the far left, so not the far left, but the second one from the far left, is showing the clock. Did you know that the clock, they've updated it where, and this isn't a new update or anything, but the second hand actually moves and you can actually see the second hand. So I use that when I want to see the seconds. So anyway, that's neither here nor there. So yeah, we got about a little over 30 seconds and then we'll get the party started. And so yeah, if you just joined us, those are like my 2 o'clock students. It's kind of like if we were in a classroom, the 2 o'clock students are leaving out, they had questions and things of that nature, and then my 3 o'clock is coming in. So yeah, that's all that was happening there. 15 seconds. Yeah. So I'd be feeling it. Like I totally be going through it, you know. It just be nonstop talking. It'd be way more talking than I would like to do, but it's okay. I don't mind. I mean, the challenge is just making sure I have energy for you guys. So oftentimes I'm like napping before a class starts. Or at least I try to get a nap in so I can have some energy and eat something. All right, gentlemen. So welcome. I'll do the best I can with the announcements. This is maybe my 3rd time going through these announcements. So, you know, if you want a more polished presentation, I would encourage you to look at the recording from this morning. You can find it on my YouTube. So on my YouTube, there are 2 main playlists that you need to access. That's recommended that you access. There's one that says fall of 2024. And so that's basically all my current sessions with college algebra from this semester. And then you have college algebra 1, you know, all pre-recorded lectures. And those are the full lectures for each section. So the fall 2024 one, I update after each section. And then the other one are the recordings from the past. I see I'm kind of pausing because the things I'm trying to say, but I keep forgetting them. So that's why I'm encouraging you to use those recordings because I don't forget anything. One, I hope everyone had a great weekend. You're able to do what you needed to do. Hopefully you were able to gain full access to Pearson, all right? So also be aware these sessions are being recorded and live streamed to my YouTube channel, and attendance is being recorded automatically. So it records when you show up, when you leave, right? So if I notice that people are leaving early or aren't staying for the full time, then you know, you could potentially not gain your attendance credit, right? So the simple thing is just get here and zen out. And I don't hound the students anymore. I used to do that where like, so-and-so, turn your video on. I can't see you. Answer this. You know, I used to do all that. And I'm like, nah, you know what? That's too much, right? So I don't really do that anymore. I don't really bother you guys. Just at a minimum, I need you guys to come in and zen out. And then, you know, I try to ask questions, but the difference is the rhythm is different than if we were like in person. So we talked about gaining full access to My Math Lab. Let me mention 3 things there. So there are 3 different ways, at least 3 different ways to purchase it. The recommended route is you log into Blackboard, you find a link that says Access Pearson All Assignments, you follow the prompts, you register as a student using your Morehouse credentials, and then through that process, you're going to be prompted for payment. That's the recommendation. Purchase it directly from Pearson. The feedback I've been getting is that there are 2 different options. One that says 150 and another that's like 120. All you need is 120. You don't need the more expensive one, right? You just need the access to My Math Lab, right? So some students are purchasing it directly from Pearson. Some students are using book vouchers, which is fine, or financial aid or whatever. If you're using a book voucher and you're purchasing it from the Morehouse bookstore, all you need to do is purchase a My Math Lab access kit, right? So just make sure whatever you're purchasing, it comes with an unused My Math Lab access code, okay? And then the third option, if you do buy a book, a physical hard copy book somewhere, again, make sure it comes with an unused My Math Lab access code, right? That's the main thing. You need access to My Math Lab. Because that's basically how the grade is going to be calculated for homework, quizzes, and exams. I want to say all homework and quizzes for the entire semester are available right now, along with my recordings for each section are available right now. And so the only thing that has a scheduled release are the exams. I think exam 1 is scheduled to release, I think it's like during week 5, basically every 3 sections. So we're starting section 1-1 this week. Next week is 1-2. The week after that is section 1-3. So then when we move into week 5, that week is devoted to testing, right? So usually on testing weeks, I just log in and kind of use class time as Q&A and office hours, right? I don't do anything in particular. Just trying to make sure, hopefully there's no echo. I'm trying out something a little different. So right now I'm using a microphone. And so when I'm using my microphone, I can't hear your audio, but I am monitoring the Q&A and the chat. So if you have questions, feel free to either type it in the Q&A or put it in the chat. And we'll address them as needed or as we see them. And then maybe at the end of class or towards the end of class, I'll remove the microphone. So if you need to like do some audio or speak audibly, you can. Let's see. The chat. Oh, and then also, I usually just remind my groups. I know that I usually just encourage my groups to have a group me going. I think I forgot to remind my earlier group. Maybe I did, maybe I didn't. This is the 3 o'clock. So yeah, hopefully you guys have a group me. Also, this section has a lab associated with it. So let me kind of do this disclaimer on the lab. The lab is essentially a separate class from this one, right? So this is our main class. I'm facilitating. We have our own set of homework, quizzes, and exams. Anything with the lab, you have to consult my colleague, Dr. Lamar. So to find information on the lab, you log into Blackboard, and when you get to our course, on the left-hand panel, you're going to see a link that says Alex Lab. You click on that link that says Alex Lab, and you'll find like the syllabus for the lab. You'll find the contact info for Dr. Lamar. So when you contact her, I think she sent out an email saying that the lab starts it might be this week, I'm not sure. But, you have any questions with the lab, you have to consult Dr. Lamar, contact her ASAP, and then follow her instructions. I think it starts this week. All right, so just reach out to her to get those details. And so again, the main structure is, we're going to have our own set of grades, whereas it's going to include the homework, quizzes, and exams. Whatever we do together counts for 90% of your overall grade. With Dr. Lamar, you follow her instructions. Whatever you do with her, she's going to give me a grade for each student. All right, she's going to give me a grade for each of you. And then whatever grade she gives me for each of you, I'm going to scale that so that it's 10% of your overall grade. Again, questions with the lab, you have to. I'm not really sure. I don't know the details of the lab, so you'd have to ask Dr. Lamar. So that was a good question though, because hers is different. She has her own set of rules and things. It's a whole different thing. So just consult her, and she'll make sure that you're taken care of. So we talked about the lab. We talked about the homework. Okay. Let me mention the following. So today we're going to do our best to make our way through section 1.1. Let me change this view. That's a single page. Okay. So we're going to be making our way through chapter 1, and today we're going to focus on section 1.1, graphs of equations. So this is just a recommendation. This is not required, but it's highly, highly recommended, is to create your own notebook. You're creating your own like manual or manuscript. The more neat and organized that you can be, the better, right? So that entails like slowing down, reviewing your notes. Now, when you're building your own notebook, the magic happens, or it only serves you if you make it yourself, right? Like, say the exam comes around, obviously, you can do open notes because it's remote, so I'm not going to make a big deal about it, anything like that. But it's the difference between making your own notebook and using some notes, right? Having access to notes is one thing, right? And so then you're just constantly flipping back and forth trying to see if you can find something that can help you. Versus if you make the notebook yourself, that includes the notes, the homework, and your formula sheet, then by the time the exam rolls around, you'd be like, wait a minute, I saw we did that question in the homework. Here it is right here. Same question with different numbers. But you wouldn't really be aware of that unless you build the notebook yourself, right? You know, so that's like the long and short there. So the recommendation is that each of you are creating your own notebook. And again, the more neat and organized that you can be, the better. So for instance, right now we're working on section 1.1. Again, there's three recommended sections in your notebook. One section has a copy of the notes. So when it comes to the notes, all these things that you're going to see me writing, you can actually access them on Blackboard right now. Now, because it's the 3 o'clock, you can actually pull a copy of the 9 o'clock notes. When the 2 o'clock notes, it's the same content. And I'm going to make a copy of yours available at the end of class. And so anything that you see me writing, I'm going to make a copy available. And so to access it, if you go into Blackboard, go to, like, it's going to say Box link. You click on that, and it's going to take you to another app called Box. Use your Morehouse credentials. You should be able to pull a copy of the notes there. I think I actually do have a copy of notes for the entire semester. It's like reference notes from previous courses. You can use those, or you can use ours, whichever floats your boat. But yeah, in your notebook, so you have a copy of the notes, neat and organized. You have a copy of the homework, neat and organized, right? So when you're doing your section for the homework, you might have your title. This comes from section 1.1, graphs of equations. Here's question number 1. The question ID is 1.1.5. It's question 5 from the back of that section. Here's a copy of the original question. Here's all the supporting details on how to solve that question. Here's my final answer in a box. Next, here's question number 2. Here's the question ID. This comes from section 1.1, question number 9. Here's a copy of the original question. All supporting details, final answer in a box. And you pretty much do that for every homework question. So the better you're able to build your notebook neat and organized in a fashion like that, the more it's going to serve you. If you have a copy of notes, but you didn't build it yourself, then it's just like having a book and you're just flipping back and forth. It doesn't really serve you, right? Again, the magic comes in creating this manuscript yourself. It's tedious, it's boring, but that's how you learn it, right? We haven't got to that level of, like in the Matrix, being able to just download, oh, I know Kung Fu, right? No, it's not like that. Like, we have to, it's tedious. You have to spend time. It takes about, my recommendation is to set aside anywhere from 2 to 3 hours, approximately 4 times in the week for this content, all right? That's what it takes. And approximately 2 to 3 hours, about 4 times a week, When I was a student at Morehouse, the time that I set aside to do this stuff, I did work study. And I worked in Archer Hall. And so in Archer Hall, when I was doing work study, I'm sitting at a desk for like hours on end, like 4 or 5 hours at a time. So that's when I would do all my homework. I'm just sitting at this desk. People come into the rec center. Can I see your ID? They flash it. They go on about their way. And in the interim, I would just sit there, and that's when I would do all my homework. So I was essentially getting double paid to do my homework because I got work study, and I was there on scholarship. So that's how I did a lot of it, at least at Morehouse. Grad school is a little bit different, but yeah. Let me see if there's anything else. So, and then the third component of the notebook is the formula sheet. So, my recommendation is, like, at the end of your notebook, you have a sheet that every time we come across a formula, I'll try to highlight them, but every time we come across like an important formula, update your formula sheet. All right. And so then that way, and you put it at the back, so it's easy to find, maybe like 1 or 2 pages, maybe 3 pages, something like that. And you're good, G, and you're good to go. So again, the more neat and organized you can be in creating your notebook, that's really where most of the learning occurs, right? But having a copy of the notes, it's not going to serve you the same as making it yourself, right? So you have to kind of like slow down and set time aside, and I know that can be a challenge in this day and age, but that's what it takes, right? Okay, and again, as usual, if you have questions, right now I can't hear your audio because I'm using my microphone, but feel free to either type it in the Q&A or the chat. I'm monitoring these. Also, this session is being live streamed to my YouTube. Hopefully you're subscribed to my YouTube and your notifications turned on. and the attendance is automatically being recorded. So it logs when you show up and when you leave, right? Okay. So I think that's it for morning announcements, right? Vital information for your everyday life. I don't know if you guys know that reference. But yeah, so let's kind of get into the content. And again, whatever we don't finish together, I do expect you to use my recordings to fill in whatever we're not able to do together. Yeah, okay. So here we're looking at section 1.1, graphs of equations. Now, I know I had a gentleman that was in my 3 o'clock. I don't know if you're here now or not, because I know you were trying to get into the early, sorry, that was in my 4 o'clock. I don't know if you're still in the 4 or if you're here now. It would be nice to know if you're here, but I'm not going to worry about it. I'll know by the end of class. Okay. So with section 1.1, graphs of equations, a few objectives. 1, plot points in the Cartesian plane. Okay. 2, find the distance between 2 points. 3, find the midpoint of a line segment. 4, sketch the graph by plotting points. 5, find the intercepts of a graph. 6, find the symmetries in a graph. And 7, find the equation of a circle. All right. So we have this kind of alludes to a couple of formulas that we can anticipate. We got the distance formula and midpoint formula. All right. So it's coming down the pipeline. Okay. So we have some definitions, an ordered pair of real numbers. So we call this an ordered pair because it's a pair of numbers where the order is important. The first component is our x coordinate, and the second component is our y coordinate, right? So when we go to plot these points, we would start at the origin, and the x's run horizontal or side to side. The y values run vertically or top to bottom, or up and down, right? So if we start at the origin, this is basically saying these are instructions on how to get to a specific point on the flat surface. This is saying start at the origin, go left 3, and then go up 1. All right, and then that's the specific point that this is referring to. Okay. All right, and so we see it here. So we have the coordinate plane. We have our positive x-axis in this direction, right, with this corresponding label, right? We know that that's the x-axis. Positive y in this direction with this corresponding label. Okay. So then we take the x-axis and we'll lay it orthogonal to the y-axis, which just means, in this context, it just means at a 90-degree angle. And so it breaks the flat surface up into 4 quadrants. So we have quadrant 1, where x is positive and y is positive, right? So if we're rotating in this direction, what do we call this direction of rotation? What is direction? You feel free to put it in the chat because I can't hear your audio. All right. Anybody? No takers? Going once, going twice. All right. So yeah, that's called counterclockwise, right? Like if you think about the hands on the clock generally go in this direction, right? So when we go to count the quadrants, it goes in the reverse direction, which is called counterclockwise. That's correct, right? So we start with upper right hand region. It's called quadrant 1. That's where x is positive and y is positive. If we rotate counterclockwise, that takes us to the next quadrant, which is quadrant 2, where x is negative and y is positive. If we continue rotating, this puts us into quadrant 3, where x is negative and y is negative. And we finish in quadrant 4, where x is positive and y is negative. Okay. All right. Yeah. Okay, so the graph of the order pair, is basically like the point that we plot or whatever. So I'm going to leave this as an exercise. Can I still paste that? Nice. So I'm pretty much going to leave. This one isn't too terribly bad. Plotting points. So with each point, we're going to start at the origin. The first coordinate or x coordinate tells us how far either left or right to go. If it's negative, we go left. If it's positive, we go right. And then the y value tells us how far either up or down we go. If it's positive, we go up. If it's negative, we go down. What quadrant is quadrant B? What quadrant is this? Is this one located in? Yeah. So quadrant 2, right? So we see it here. So for instance, if this is quadrant 1, 2, 3, 4, how would you describe the location of E? How would you describe the location of E? I think that is the first time that somebody described it that way. It was this. I mean, it crosses the X, right? So it's basically on the X going. All right, so share my screen, start the broadcast. Okay, let me make sure that my audio is still working. I guess, yeah, I can see I guess it's okay. All right, I think we're good. All right, let's let that be. Okay. All right, so if we have a formula sheet, we have the Pythagorean theorem. And essentially what it is that, a mathematician was working, and he noticed that if you take the square, and these are just like rough sketches, and I know they're not squares, but it's just I'm kind of like short on space when it comes to this. But if you take the square of the sum of the squares of the shorter legs is going to be equal to the square of the longer leg, right? So now I'm gonna get rid of all this stuff, right? So the sum of the squares of the shorter leg is equal to the square of the longer leg. In other words, a squared plus b squared equals c squared, right? So this is a property that we use, heavily throughout mathematics, right? And so let's look at the following. Now, let me see if I can get this to work like that, Go away, come back. Nice. Yep. Like that. Come on. Looks good. Okay. It's behaving better this time. It wasn't behaving this well before. Okay. All right. So let's consider the Cartesian plane, right? So like for instance, say this is our origin. So we have the positive x-axis in this direction. Okay. Say we have the positive y-axis in this direction. Okay. Let me see. And we want to consider 2 points. Let's consider this point P about here, and a point Q. We'll put it about like here, I guess. That's fine. So this is P. This is our x1, y1. This is Q. This is our x2, y2. Okay. And we want to consider the distance between these 2 points, P and Q, right? Where this here corresponds to x1. This here corresponds to x2. This here corresponds to what? y1. And over here corresponds to y2. Okay, so you should see a familiar shape. Right? You notice something familiar, right? I think just a moment ago we said that this could be like our short leg A, short leg B, and hypotenuse C. So now we should be able to make a correlation between the Pythagorean theorem and the distance between 2 points, right? So let's see. Say we want to find the distance of A. Can anybody describe to me maybe in the chat, how could we find this distance of A? How could we find this distance? Right? How could we find the distance? Two, how could we find that distance? Right, I got it. Once, went twice. Forever hold. Okay, yeah, right. I see subtraction. I see x2 minus x1, right? Close for that second one, but it's essentially so. If we want A, right? If we want A, so right here, a moment ago we said a squared plus b squared equals c squared. So if we want A is going to be the distance between x1 and x2. So we could say something like x2 minus x1, and we're going to take the absolute value because we want the distance. What does absolute value mean? Can someone describe to me what do we mean by absolute value? What does that mean? What does absolute value mean? Going once, going twice. So absolute value is basically the positive distance away from zero, right? So absolute value is a positive distance away from zero. For instance, if we like, what's the absolute value of 6? Well, it's just going to be 6. What's the absolute value of -3? Well, it's going to be 3, right? So absolute value is the positive distance away from zero. So if we want the distance between A and B, we're going to say, if we want the distance of A or the length of A, you know, we can say x2 minus x1 and then take the absolute value. Similar for B, right? If we want the length of B, we can say y2 minus y1 and then take the absolute value. Okay, because we want the positive distance. Okay, so now if we take these two expressions and plug them in to Pythagorean theorem, now C is our distance from P and Q. So then we have our distance from between P and Q, quantity squared. That's going to be A squared, which is x2 minus x1 quantity squared, plus y2 minus y1 quantity squared. Okay. So another question is, if absolute value is going to be a positive distance, what happens when we square a positive number? What happens when we square a positive number? Does it stay positive? Does it become negative? What happens if we square a positive number? It stays positive, right? Okay. So because it stays positive, then we can actually just lose the absolute value here, right? And so when we do this, and one last question. Suppose we want to move this squared to the other side. What's the inverse operation of squared? How do we get rid of that squared? What's the inverse operation of squared? Square root, right? So if we wanted to get rid of that squared and isolate that the distance between P and Q, we would take the square root. Okay, I lied about the last question. That was not the last question. Whenever we do square root, generally speaking, what symbol should we also include whenever we do square root? Or an even root? What symbol do we need? We do an even root. Just curious to see where you guys are. Okay. So I'm not seeing it. Now, usually, well, no. So usually whenever we do square root, we need to do plus or minus, right? Whenever we do an even root, like fourth root or anything like that, we do plus or minus. But in this context, because we're only working with like the positive distance, we're just going to take the positive. So this symbol cancels that one. We're only taking the positive root. Normally it's plus or minus, but in this context, we're only taking the positive. And then once we put all this together, that's where our distance formula comes from. So the distance between 2 points P and Q is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's where the distance formula comes from. Okay, let me see. Let me go to view settings, seamless. Thank you. Where are my options? Oh, it just went away. Okay. Yes. Nice. Okay. That's exactly what I want. Cool. Boo. Single page. Sorry. Okay. So in green, so now we've made a connection. We've kind of explored the correlation between how we use the Pythagorean theorem to derive the distance formula, right? And so I think we have it officially on this next slide. So again, if you have like a formula sheet, this is basically what we were building up to. Distance formula, right? So I'll try to highlight pertinent formulas like you see here. If you have a formula sheet, it's a good idea to update it with this guy. I think we also have the Pythagorean theorem. Okay, we got a solid 15 minutes, so I'm gonna keep pressing forward. Okay, and again, this formula came out of the Pythagorean theorem. So with these formulas that we have throughout this course, you know, it doesn't hurt to know how to derive them. In other words, where the formula comes from, right? There used to be this poster when I would walk around Dansby Hall that would say something along the lines of, there is no such thing as complex. What we consider to be complex is just a long string of simple ideas, right? So when you see this distance formula, it may look complex because it's like, you know, subscripts and all of these, but all it is it's just a long string of simple ideas. If you understand a squared plus b squared equals c squared, and then you know how to find the distance of A on the coordinate plane, the distance of B on the coordinate plane. You put those ideas together like we did a moment ago, and bada bing, bada boom, boom. The distance formula, right? But again, long story short, it doesn't hurt to derive formulas. What we consider to be complex is really just a long string of simple ideas. All right. So you know, take that, take it or leave it, do what you as you will, as you see fit with that information. Okay, let's keep going. And so what this is just reiterating what we kind of explored on the previous slide, where we're deriving the distance formula. Okay. All right, so this, I think I ended up having to leave it as an exercise, paste. Oh, shiesty. Okay. Let me go pull my old one. Dang, that was way back there. Oh, there it is right there. Nice. Let's try that again. Let's copy. Okay, paste. So I'm gonna have to leave this one as an exercise. Also, you can find a video presentation of this on my YouTube channel. So in the playlist for College Algebra 1, you go to the full lecture for section 1.1, and it goes through these details. You know, we only have a little over 10 minutes left, and we still got like 40 slides. So obviously we don't have enough time together. So on like Mondays, again, we'll do the best we can to go through the lecture. On Wednesdays, my goal is to go through as many homework questions together as we can. So again, with today, whatever we don't finish together, I do expect you to use my recordings. Honestly, in an ideal world, we can get as many of you as far ahead as possible. You don't really have to wait on me. Like, the recordings are the exact same content, and I've already put the things I want to say in those recordings. So if you watch them in advance, go ahead and get the assignments out of the way. Then just show up and send out, and then you just be waiting on the exams. That's in an ideal world, right? And it's already worked out here. So when you're doing these exercises, try, again, in an ideal world, you want to try to get all the way in and try to generate your own answer. You know, don't start with the answer, because that's not going to serve you. But if you can like just have a question like this and just using the information that's given and generate your own question or your own answer, the better you're able to generate your own answers and they're correct, the more often that happens, the more you're actually learning. But if you start with the answer and you work backwards, you know, it doesn't really sink home. It doesn't really sink in all the way when you do that technique, right? I mean, obviously you do it as needed, but in an ideal world, I can show you something just like this, and you're able to work it out. You generate your own answer, and then you compare at the end once you've generated your own answer, right? So that's really the meat and potatoes. Being able to generate your own answers as best you can. If you can't, you get stuck. Then you start digging and researching. Then you start working backwards at that point as best you can. So again, here's a detailed version worked out. So you have access to this. So then here's another one. So on your formula sheet, this is the midpoint formula. The way I remember the midpoint is the average of my x's, comma, average of my y's. That's how I remember the midpoint formula, right? So for right now, again, I'm going to have to leave all these as exercises. Okay. And here's the type version of that, so I'll let you discover that on your own. So when we say an order pair satisfies an equation, what we mean by that, so the solution to the equation is going to be a set of order pairs that make the equation true. When you have your x value along with its corresponding y values, you plug that into your equations and it makes it true. Those are the solutions to the system. For our context, generally speaking, the x is going to be our independent variable, right? We're just going to choose values of x. And our y value is oftentimes going to be referred to as the dependent variable because the value of y is going to depend on whatever value of x we choose, right? You have to forgive me. I'm talking nonstop, so I'm fading. But that's part of the challenge is keeping your endurance up. So again, the graph of an equation is going to be a pictorial representation of all solutions of a system, right? So the solutions are going to be the order pairs. Many times we have infinite solutions, but we can connect them in like curves and lines, right? So let's see it in action. So I'm going to leave this one as an exercise, but the idea here is, we chose these values of x. We would pass these values of x through this function, this value of y. We generate the corresponding value y's, and it'll generate a set of ordered pairs, okay? And so I think we have it typed here in full detail. So then we will plot those order pairs and connect them with a smooth curve. We get an image like this. I'm also kind of skipping these because I think you can handle these. These aren't too terribly bad. If you need to see it in detail, again, you have to use my recordings. It's all in section 1.1, pre-recorded lecture. Let's see what's going on here. Oh, yeah. Yeah, they do stuff like that. Okay. So sketching a graph by plotting points, you have your set of ordered pairs. That's the solution to an equation. We plot them and we try to connect all the points with either a smooth curve, or if it's a straight line, then we use a straight edge to connect our points. So okay. So then some more terminology. The x-intercept, right? If we consider the word intercept, that's where a graph crosses or touches that axis. So the x-intercept is where the graph crosses the x-axis. The y-intercept is where a graph crosses the y-axis. Along the x-axis, let me see. Along the x-axis, the value of y is always 0. Along the x-axis, the value of x is always 0. Okay. If we wanted to find the x-intercept, we set y equal to 0. If we wanted to find a y-intercept, we set x equal to 0. Okay. And keep in mind, I'm going to make a copy of these notes available. There's actually a copy available right now from our earlier sessions, and I'm going to make a copy of this available in a little over 10 minutes. You can access it if you go to Blackboard, open up our main folder that says College Algebra 1, and then I think it's item number 2 that says box link. Once you click on box link, it's going to take you basically in the box, and that's where I load the notes. So also you can access like a reference file, so my notes from previous semesters, and it should be basically all of these with the handwritten portion filled in. So I left it there as a reference for you all to use at your discretion. So as you can see, this one is an exercise. Okay. And it's typed here. So symmetry, when we're talking about symmetry, these are where points are equidistant and mirror image or mirrored about some point of symmetry. In this case, we have an axis of symmetry, so the points P and P prime are symmetric about the axis L, right? So they're equidistant, they're both the same distance from L, and they're mirrored about L. Okay. So we have 3 different tests for symmetry. First, we have a test for y-axis symmetry. With y-axis symmetry, whenever we have x comma y, we also have negative x comma y, right? And so when that happens, the y-axis serves as an axis of symmetry, and so all our points are equidistant and symmetric about the y-axis, right? So whenever we get a point on the left, we get a point on the right, and vice versa. Okay. We'll explore how to do the test for y-axis symmetry. I guess I'll just say it now. So if we wanted to test for y-axis symmetry, we would replace x with negative x, we simplify, and then, if we get back to the original, that means we have y-axis symmetry. I think we have, let's kind of finish this and we'll touch on that again momentarily. Okay, so we talked about y-axis symmetry, then we can also talk about x-axis symmetry. With x-axis symmetry, whenever we have x comma y, we also have x comma negative y. So notice that the x values stay the same, but the y values changed, right? So whenever this happens, the x-axis serves as an axis of symmetry, and whenever we get a point on top, we get a point on bottom, right? So the main thing that to notice, to pick up on, with x-axis symmetry, the y values changed. With y-axis symmetry, the x values changed. Okay. And then the third one that we have is origin symmetry. With origin symmetry, whenever we have the ordered pair x comma y, we also have the ordered pair, they both change, negative x comma negative y. And so all of our points are equidistant and symmetric about the origin, and they kind of like make an S pattern almost. Okay. So with origin symmetry, again, both x and y, they both change. Okay. Okay, we got a couple of minutes left. Okay. So again, if you want to see the details on how to do a test for symmetry, I'm going to refer you to my pre-recorded lecture, so you can find the details here, okay? Or find it in that recording. I'm going to have to piggyback off of that. You have some details here as well. Okay, I'm going to have to leave all of this as an exercise. So then when it comes to a circle, right? The center of the circle is going to be labeled h comma k. The radius, which is the distance from the center to the circle itself, is going to be r. Okay. And on your formula sheet, this is another good one. Now, we don't do too many with the circle formula, but it's still a good idea to have this ready to go. Where h comma k is going to be the center of the circle, and r is going to be the radius of the circle. This is an equation of a circle in standard form. Okay. So I'm going to have to leave this as an exercise. This one as well. And again, these details are worked out in my pre-recorded lecture. And it wouldn't hurt. This isn't necessarily a formula, but this is the general form of the equation of a circle. It wouldn't hurt to add that to your formula sheet as well. Label it the general form of the equation of a circle. Have to leave this as an exercise. How do I redo? Okay. And I think that gets us to the end. Okay, the timing is pretty decent. We got pretty much out of time. Are there any burning questions before we go our separate ways? Going once, going twice. So, things that you need to be aware of. Gainful access to my math lab. On Wednesday, we'll go through as many of the corresponding homework together as we can. So we'll do the best there that we can do. I feel like there's more, but I'm totally faded now. Any other burning questions before we go our separate ways? Going once, going twice. Forever hold your P's and rights. Okay, if there aren't any burning questions, we're going to go ahead and end the session here. Attendance is automatically recorded. So again, it logs when you arrive and when you leave. So kind of be aware of that. If I notice you're not staying, you might not get attendance credit. The best practice is just show up and zen out. And I think that's a fair compromise. Again, if there aren't any burning questions, we're going to go ahead and end the session here. One other thing is, if you missed last week, you want to bring it to my attention now so that I can be sure to mark you as excused. Otherwise, we'll end the session here and from one beautiful mind to another. Enjoy the rest of your evening, and we'll meet back on Wednesday, same time, same place. All right, guys, take care. Peace. All right, I'm going to stop sharing my screen. And let me see, I still have another group that meets in about 15 minutes. So I'm just going to stay on the call, but I'm just going to mute myself. So and I'll go ahead and remove my microphone. So speak audibly, you can. I'm just here. So if you need to unmute yourself, feel free. Otherwise, I'll see you on Wednesday.
Siri, turn the
Hello?
TV off. All right.
Hello?
So yeah. So any update on moving to another course or?
No. So I'm working on it though. I have to go see my advisor tomorrow. I tried to do it email and then they're like you have to come in person to get your classes thing. So I'm gonna go tomorrow between 1 and 4 and hopefully move into the 3 o'clock section.
Okay. So I think what I'll do today. So basically, I have recordings from my sessions earlier. You can listen to either like the 9 o'clock or the 3 o'clock
Okay.
on my YouTube channel. I'll just probably stay on the Zoom call if you have questions.
Okay,
But
cool.
you're not gonna make you stay or anything like that. But I'll probably
Okay,
just try.
great.
If
All right.
if I'm not on the Zoom call, then you have my office cell phone number.
Right.
You can just call me and we can talk about anything that you need to talk about. But I'm gonna rely on my recording. So
Okay, great. That's fine. I'll definitely watch that.
I'm sorry. You know how to find them?
Yeah, it's on your YouTube channel, right?
Yeah.
That's on your Blackboard.
Yeah, that's correct. Yeah.
Yep. So I
Okay.
just go there and then watch the video. And is there any homework or anything that I need to have before Wednesday?
So the homework is assigned for the entire semester.
Okay, got it.
It is due on a weekly basis, but there's an automatic extension. It's like a 5%
Okay.
label.
Cool.
Were you able to access my math lab? Okay.
My math lab, I did not actually do that. Oh,
You're able to log into the portal?
yes, I am. So I'm looking at it right now. Yeah, because
Okay.
I had to purchase something, right?
Right, that's what I was gonna say. It costs about the students have been saying there's about two options. One that's like a one-time payment, like a 120. Other that's some subscription. You only need the one-time payment.
Okay,
You don't
cool.
need.
I didn't do that because I wanted to make sure that I was in the course I would be staying with before I did that, but I'll go ahead and do that too.
Yeah, let me think. I mean, yeah, that's fine. Because even if you do move to the other section, you can still use the one that's already there. So,
Okay, cool.
yeah, whichever.
All right.
Okay.
Definitely, I'll handle that.
All right, I'm here if you have questions.
All right, thank you.